we are going to take up the problem of isogram. So what is isogram? Given n letters, we need to find how many isogram words can be formed. A word is said to be isogram if it is formed without repeating a letter. For example, the word isogram itself has the property which does not have a letter being repeated. For example, we take apple, the letter P is being repeated again, so it is not a isogram. So we have to be very meticulous in choosing the words which doesn't have the letters being repeated, so that words can be termed as isogram. So how do you solve this problem of finding the isogram words? So here the length of the word can only be a maximum of n. The first letter can be of n letters. The second letter will be any of the remaining n minus 1 because we have already dealt with the first letter. The third letter will be the any of the remaining n minus 2, and we carry on with the operation, and the nth letter can be the only one left. So therefore the total number of isogram words that can be formed is can be of the form n star n minus 1 star n minus 2 star etc. up to 1. So if you are familiar with the notation which is given at last, we can notice that it is of the form factorial. So here the input is number of letters n, output is n factorial, that is factorial of n. So the alternate ways for the solution can be iterative way or it can be recursive. So how do you solve this problem of factorial? So example is we are taking here is the finding the factorial of n which is greater than or equal to 1. So what you generally have is n factorial is n into n minus 1, n minus 2 etc. up to 1. But here we are going to follow the divide and conquer strategy, where we say if n is equal to 1, n factorial is equal to 1, we give a direct solution. Else what you can do is you can say n factorial is equal to n star n minus 1 factorial. That is the alternate solution you can give. So for example, if you take the input as 3, so if n is equal to 3, so 3 factorial is equal to 3 star 3 minus 2, that is 3 star 2 factorial, that is 3 into 2 into 1, that is 6. So the solution may be the same, but the approach here is different. So we are more concerned about the approach. So if you see this presentation, so not to find the n factorial, we say n star factorial of n minus 1 will give you the final result of n factorial. So the glue is applied between the parts n and factorial of n minus 1 to obtain the solution n factorial. Next we are going to take the concept of Tower of Hanoi. So Tower of Hanoi is a very famous concept that is being proposed. So it was a mathematical puzzle that was invented by a French mathematician, Edouard Lucas, in 1883. The game consists of 3 pegs named as source, the destination and the auxiliary, and it starts by having few disks stacked in increasing order of size in the source peg, and the objective here is all the disks must be moved from source peg to the destination. That is the ultimate objective of Tower of Hanoi. So we need to see how this is being done. So there are some rules we need to follow to complete this task. So we can move only one disk at a time. That's the golden rule you have to follow. The larger disk may not be placed on top of a small disk. That is the second rule you need to follow. And each move consists of taking the upper disk from one of the rods and sliding it onto another rod. So these are the rules we need to follow in order to solve the puzzle. So what is the input for the Tower of Hanoi problem? So the number of disks in a source pole, that is n. The output will be the description of movements, and the alternate solution for this particular problem can be either iterative or recursive, or it can be bitwise algorithm. So this might be the initial configuration. What is given to us? All the disks are being stacked on the source peg, and the final solution is all the disks need to be moved on to the destination peg. In between you see a rod, that is the auxiliary rod. So the recursive algorithm to solve the Tower of Hanoi problem is discussed here in this slide. So when the number of disks is 1, we can directly move from the source to the destination. We need not have any trouble in that. Otherwise, what we have to do is we have to move the n-1 disks from source to auxiliary peg by using the destination peg as intermediate. We have to move the nth disk from source to destination peg. We need to move n-1 disk from auxiliary peg to the destination peg by using the source peg as intermediate. So these are some of the steps we follow in this algorithm. So if you write a source code, like a pseudocode for this Tower of Hanoi problem, so you can say solve of n, from, inter, 2. If n is 0, we will be exiting out of the particular problem. Else, we solve if n, we have an input of n-1, from, to, and inter. So if it is the case, we are going to move from the source to the destination, and we need to call the solve again, where the input is n-1, auxiliary, source, and the destination. So this is the pseudocode for solving the Tower of Hanoi. So for each call of function, the from, the to, and the inter codes are used. So now we are going to take up a test case. When n is equal to 4, the function is called for n is equal to 3 because it is n-1. When n is equal to 3, the function will be called for n equal to 2. When n equal to 2, the function is called for n is equal to 1. When n is equal to 1, the base case is reached, and we move the disk from pole to the to pole. And the steps for executing pseudocode of Tower of Hanoi when n is equal to 4 will be discussed in the coming slides. So the change of from, to, and the interpex in call of first solved in the pseudocode when n is equal to 4. So if the value of n is 4, we move the disk from source to destination, keeping the intermediate as auxiliary. When input is n is equal to 3, the disk is moved from source to auxiliary, and we use the intermediate as destination. When the input is 2, it is moved from source to destination, and keeping the auxiliary as intermediate. When it is 1, the disk is moved from source to auxiliary, keeping the destination as intermediate. And when the input is 0, we move the disk from the source to destination, keeping the inter as auxiliary. So if you see this particular slide, you will understand how the step-by-step solving of Tower of Hanoi is carried out. So initially all the disks are stacked up in the source. Next we start moving the disks from the source. So only one disk need to be moved at a time. So that is being followed. And if you go to the previous slide, you can see in this equal 4, it is moved from source to destination, keeping the intermediate as auxiliary. So we keep this as an intermediate. This is auxiliary rod, we keep it as an intermediate. And another rule is the larger disk cannot be over the small disk. That is another rule we have to follow. So if you follow this step by step, right? So next step, this particular disk is moved on from the auxiliary, moved from auxiliary to the destination. So if you see the forthcoming steps, you'll understand how the Tower of Hanoi problem gets solved based upon the algorithm we were proposed here. This is the recursive algorithm that is we have proposed, and this is the pseudocode we are proposed to solve the Tower of Hanoi. So when n is equal to 3, so the disk is moved from source to destination. So if you see in the next step, it is moved from source to destination, keeping the destination as intermediate, and this is moved from source to the auxiliary. And n is equal to, the disk is moved from source to destination, keeping the auxiliary as intermediate. So that is the next step. And finally, if n is equal to 1, the disk is moved from source to destination, keeping the auxiliary as intermediate. And if n is equal to 0, it is moved from source to destination, keeping the auxiliary as intermediate. Okay, so how do you learn a natural language? So you have to learn the alphabets, then the words and the sentences, and finally we go for the paragraphs. So learning of a programming language is also similar to learning a natural language. So we have to learn the alphabets, then digits, the specific symbols first, then we need to know the concepts, variables and the keywords, then we go for instructions, and then for the program. So we solve the isogram problem using the computer. So we want to solve the problem in C as this case is concerned, and the value of n is the number of letters that has to be stored in memory. So we need to store the data in memory. We need to name the location in memory, that's called as a variable, and the group of characters represent a variable name. There are different types of variables based on values that can be stored in memory, and the value of n has to be got from user. That is done by means of scan. So how do you solve it using a computer? So we have to find n factorial, which is equal to n cross n minus 1 factorial, that we have already seen. Here n cross n minus 1 factorial is an expression. How expressions are defined in C is this is the way we use an expression. Then we have to find n minus 1 factorial, which is n minus 1 star, n minus 2, and so on. So we can say an arithmetic expression may have many operators, and the order of execution is defined by the precedence of operators. After computation, we need to show the output to the screen by means of the printf statement. So printf and scanf cannot work alone. We need the main function. So if you see a C program, the base will look like this. So it will have 3 constant directives, which we call it as a header file. So which is decided by a hash. So it is nothing but a predefined library which we can call and which we can use it in a program. And then we can have the global declarations, which is optional, and usually we don't prefer global declarations. Then we have the main function along with the return type, where it is integer. Most of our programs will have void, which is because we don't have any return. And the local variables we need to declare after we initiate with the main function. So all the variables used in this function must be declared in the beginning. That's a good practice. And then we need to declare all the statements associated with the main function. Then coming to the function, we have given here as void f1. So we don't have any return type here. So we need to declare the variables that are associated with the function and also the statements. So this is how a C program will look generally. So what are the components that can be a part of C program? So it can be comments, variables, preprocessor commands, functions, and statements and expressions. So these put together form a C program. So when we talk about the partial code for isogram problem, so first we need to declare the header file. That's base header file. We use here is include stdio.h. That's the standard input output header file, which deals with all the input and output functions. Then we go for the main function, where we need to declare the variables to store the letters and number of isogram words, get the value of number of letters from the user. Here we are going for a user input driven program. If the number of letters is less than or equal to 0, then we have to give an error. We have to multiply all numbers from n to 1 to find the number of isogram words that can be formed. Finally, we need to print the number of isogram words that can be formed. So how can you give a comment in C? There are two types of comments you can give. That's a single line and a multi-line comment. So when it comes to a single line comment, it is double forward slash and can be placed anywhere. This is for a single line comment. So anything given after this in a single line is considered to be a comment. So how to give a multi-line comment? A multi-line comment can be placed anywhere. So multi-line comment starts with a forward slash star, then it ends with a star and a slash again. So any symbols written between or any content that is written between these two is ignored by the compiler. And the characters that we have in C is capital A, B, C up to Z and small a, b, c up to Z. So the uppercase and the lowercase both are accepted here, and digits accepted are from 0 to 9. We have a set of special symbols also, and we have variables, constants, and keywords also. So the alphabets, numbers, and the special symbols can properly combine form constants, variables, and the keywords. So the constant ND is the one that doesn't change at all. Variable is the one that can change. Keyword is a reserved word in the programming language, which is equal to the words in natural language with predefined meaning, which we cannot change. So we have two types of constants. One is the primary constants and secondary constants. So here we are more concerned about the primary constants. So first, let us see what is the primary constant, in which we have integer constant, a real constant, and a character constant. In the secondary constants, we have array, pointer, structure, union, and enumeration. So how do you construct an integer constant? So you need to have at least one digit, so must not have a decimal point, can be either positive or negative. If no sign presides, then it is assumed to be a positive one, and no commas and blanks are allowed. So here we are using GCC, as we are using Linux operating system. We are going to use GCC here. So GCC is a 32-bit compiler, therefore 4 bytes are allocated, and the range of values is some like, if you see like minus, from the minus range to the plus range, it is given here. So only the numbers that are given in this range will be accepted. So take for example this 4. What will be the output of this particular 4? If you see, it says we go in for the header file stdio.h, which is the standard input output. Then we go for the main function the void, because we don't have any return type, so no values returned, so we will not specify any return type. Then we have given the printf. So printf prints the output to the screen, and we are going to print a integer. That's why we are given %d. So we are trying to execute the program, so we need to give gcc first dot c. I have named my program as first dot c. So you can use any editor to type this program, and then finally we compile it, and then for executing we need to give as ./a.out. So a question is being asked here whether this output is valid or not. So if you see the output, you get a warning. It says format %d expects argument of type integer, but argument 2 has type long int. So this particular warning is being projected. Why? Because this particular number C is not within this particular range. It exceeds this particular range.